First, let's try to figure out how we would even like try to find gases on another planet.
Right, that's my first question: is how can we even know that from like a from a sensor system?
Yeah, and that's one of the big reasons why everyone was so excited about the James Webb Space Telescope, is because it would have this capability.
Okay.
So here's the idea. The way we find a lot of these planets is through this thing called the transit technique. Okay. What you do is you stare at a star for a very long time. You stare at a single patch of the sky and you look at all the stars. And what the star is going to do is it's going to dim once in a while for a few hours. It's going to dim. And then maybe 2 weeks later, it's going to dim again.
Okay.
And then you're going to wait 2 weeks later, it's going to dim again. And there's going to be a rhythmic dimming. Okay. And what's happening is you're getting an eclipse of the planet in front of the star.
Because it's basically like if I'm JWST looking this way.
Yeah.
The star is in the center of my field of view.
Yeah.
And the planet is orbiting around. It's eventually going to pass in between me, JWST, looking at the star.
Yeah.
K218, and it's going to be the whoop. And so the dips you're talking about,
that's going to be a transit. That's why we call it a transit method of finding it. These stars are so far away, and they're so small for how far away they are that they're basically points of light. You can't really resolve a circle.
Right.
Okay. You just resolve a tiny point of light, and all you can tell is its brightness. Okay. And so the brightness goes down, and then it goes back up.
Yeah.
And then it's this rhythmic pattern that tells you that there's something orbiting that star.
Right.
That's happening every 2 weeks to a month or whatever, and has some cadence, and then you can be very sure that that's a planet that I'm looking at. Okay. Now, the nice thing about the transit method is if you have a spectrograph, which is what the James Webb Space Telescope has, it's got a really nice spectrograph. Okay, especially in the infrared region, which is where a lot of gases do quantum stuff. Okay.
Yes.
So if you've got this spectrograph, what you can do is you can get a transit curve for every color.
Okay.
And the trick is that if there is an atmosphere with stuff in it, then the transit curve for different colors is going to be different.
It's going to have a different,
right? Because if suppose there's a bunch of oxygen on this planet, there's going to be a certain wavelength of light that oxygen really likes, and it's going to absorb a lot of. So what you're going to see is a transit curve for every single wavelength.
Yes.
But there's going to be one wavelength that you're going to see an even bigger dip. Because the atmosphere is going to be taking out more of that star.
Yes.
Light.
Yes.
Right?
Yes.
That is fundamentally how we use transit method to find atmospheres on these planets.
The chemical composition.
Yeah.